Hi class, I just wanted to provide this video for those of you that tried the circuit but maybe struggled a little bit because I didn't post the answer key. I just wanted to make sure you had an opportunity to go through those problems, especially with the log quiz coming up. So if you understood the problems, you found the correct answers using the circuit technique, then you can completely disregard this video. It's just optional for those of you that wanted some extra review. So the first problem, now the key to solving exponential and logarithmic equations is that if you're trying to solve an exponential equation, you change it to log form, and if you're trying to solve a log equation, as long as there's not a log on both sides, you're going to change it to exponential form. So one form kind of undoes the other. So this first problem I want you to recognize as an exponential equation. Okay, so the first step is you have to change it to log form. Okay, so when we change to log form, we write log base 7. The base of the log is the base of the exponent. Okay, and then we kind of do 1, 2, 3. So log base 7 of 405 equals, and then the third number is the exponent 2x. Okay, so you got to be able to change it from one form to the other. And again, kind of my hint, it's the base should be obvious, and then it's 1, 2, 3. Okay. So once we have log base 7 of 405 equals 2x, then we're going to use the change of base formula. So our calculator will allow us to evaluate this log if we type it in as log of 405 divided by log of 7. Okay, and our calculator will give us an answer, and then that's what 2x equals, so then we're going to divide by 2. So in the calculator, we're going to type log of 405, close the parentheses, and we're going to divide by log of 7. And then if we hit enter, okay, this particular expression equals 3.085, okay, and that's what 2x equals. So then if we want to solve for x, we have to divide both sides by 2. And so the answer is 1.543. Okay, and so we're going to look around. Sorry, let me just get this. I'm going to highlight this. We're going to look around until we see 1.543, and we're going to call that number 2. Okay, so number 2 is another exponential equation. We can't write the bases with the same base, and so we're going to instead change it to log form. So I'm going to write 1, 2, 3. So log base 5 of 186 equals x plus 1. And that kind of unlocks the rest of the problem. So now if you understand that change of base, this is equivalent to log of 186 divided by log of 5. Okay, that allows us to use our calculators to evaluate. And so we go to the calculator, we have log of 186, close the parentheses, divided by log of 5, close the parentheses, and this equals 3.247. And then we have to subtract 1. And so your answer is going to be 2.247. Okay, and so then we're going to look for that answer. 2.247 is up here, so this is number 3. Okay, so now we have a log equation. So you're going to check to see, do you have one log or two? Well, we have log base 4 written on both sides. So if these logs are equal, then their arguments have to be equal. So all we have to do here is set 5x plus 3 equal to 7x minus 5. Okay, and then we can go ahead and subtract 5x from both sides and add 5 to both sides. And so we get 8 equals 2x. Divide by 2, x equals 4. The only thing you have to check is you have to make sure that x equals 4 does not make this argument negative. So 5 times 4 is 20. 20 plus 3 is 23. And then 7 times 4 is 28 minus 5 is also 23. Okay, and so the answer works. And so the answer is x equals 4. So we're going to find x equals 4, and that is problem number 4. Okay, so notice the previous problem had the word log written on both sides. Okay, and now this current problem only has the word log written once. Okay, and so the difference is to solve this log equation, we're going to change it to exponential form. So just like when we change from exponential to log, the order is kind of 1, 2, 3. And so we're going to write 4 squared equals x plus 2. Okay, let me erase that to kind of get out of the way. So 4 squared equals x plus 2. And then we just have to simplify. 16 equals x plus 2. Subtract 2 and x equals 14. Okay, and so that's right next door. So this is number 5. All right, so again, we have a log equation with just the word log on one side. So we're going to change this to exponential form. This time we get 2 to the 5th equals 4x. 2 to the 5th is 32. Okay, and then divide by 4 and we get x equals 8. We just have to make sure that if we put 8 in for x, we don't get a negative or a 0. Well, 4 times 8 is 32, so we're good. So this answer is just x equals 8, and so we look for x equals 8. And it's right here, so this is number 6. All right, now in the next problem, notice that we have this 7 out in front. And so before we change this to exponential form, we're going to divide both sides by 7. And we get log base 3 of x minus 1 equals 3. And because that x minus 1 is in parentheses, it's all part of the argument. So we're going to now change it to exponential form. We get 3 to the 3rd equals x minus 1. Okay, 3 to the 3rd is 27, so 27 equals x minus 1, and x equals 28. Okay, and so we look for 28. That's going to be number 7. Okay, so again, we have a log equation. We're just going to change this to exponential form. 5 to the 1st equals 2x. So to solve for x, we're going to divide both sides by 2, and we get x equals 2.5. Okay, so the key to solving a log equation is to change it to exponential form. Get the log by itself, change it to exponential form. Okay, so 2.5 is going to be number 8. This is the final problem. So again, we have log on one side. 3 to the 4th equals x plus 6. 3 to the 4th equals x plus 6. 3 to the 4th is 81. Subtract 6 and we get x equals 75. Again, just do a quick check, make sure that argument is not negative. It's not, so the answer is 75, and that takes us right up here to number 1. Okay, so that is how that circuit review was done using kind of the techniques that I showed you in the day 15 and 16 videos. Hopefully some of you found that helpful.